So this is 2015 number 3, which is our resident chart problem. Although sometimes there's more than one. There might be on this test. So this is also our particle motion problem. So we are talking about Joanna, and we're given a chart of Joanna's progress as she jogs from 0 to 40 minutes. And it's important to note that her units are measured in meters per minute. So the chart is given in velocity versus time, not distance or not mile or meters versus minutes. It's meters per minute versus minutes. So the first thing that it asks is to measure the value of v prime of 16. So whenever you're asked for the derivative of what's given to you in the chart, that means that you take the slope. So we don't know exactly what the value of at 16 is of the velocity, so we just take the two values around it, and we take the slope of those. And we cannot forget our units. Now, the units in this look like acceleration because the derivative of velocity is acceleration. So your units for this problem should be meters per minute squared. Okay. Part B, so there's two parts to part B. The first part is explain the meaning of that definite integral with the absolute value of velocity. They love to ask this kind of problem. There's always a problem that says, using correct units, explain the meaning of blah, blah, blah. So here, although you might want to jump to saying, oh, absolute value, oh, that's speed, remember, this is the absolute value of the integral of the velocity from 0 to 40, and that is total distance. So this integral represents Joanna's total distance, and you should say in meters over, you can say it from 0 to minutes to 40 minutes, but you can say over the interval 0 t 40 minutes. So that's the first part of part B. The second part then, of course, wants you to do a right Riemann sum with 4 subintervals indicated in the table. So that the right Riemann sum or Riemann sum means that you start with not that first 0, 0, but you start with 12, 200. And remember, the Riemann sum for rectangles is the area of a rectangle, which is length times width. So there's no other fancy formula. You don't need a 1/2 or squaring anything or anything like that. So it should just be that delta x times the y value. So it should just be the delta x times the y, right? It's kind of an abbreviated version of the formula. So the first one, so my first delta x is the difference between 12 and 0. And we start with that second height, which is 200. Now, really what you want to make sure you're doing is, because you're actually finding the absolute value of the velocity, you should be using the absolute value of the velocities. So that first one we don't need to worry about. The only one we really need to worry about is later on. So then now the second delta x is 20 minus 12. 20 minus 12 comes from the chart. The second value is 12, the third value is 20, and then the minutes. So the difference of those two is 8. And then the corresponding velocity is 240. And then this is the one we need to worry about, the sign. So the difference between 20 and 24 is 4. And we see that is, and I've got my absolute values around it, so it's fine. And then the last one. Now, you might be thinking, how am I supposed to do this without a calculator? Well, they gave you still pretty easy values. You might have to do some calculations on the side, and that's fine. I had to do some too. But, you know, like, you should be able to do these relatively quickly, and you shouldn't be whining about it. So you just do them fast. Make sure you're being careful. You end up getting... And if you add these all together, you get meters. This is what you get. So that is part B. So that's the approximation of the total distance. Part C, now we're talking about Bob riding his bicycle. So Joanna is now a thing of the past. They're not even comparing his progress to Joanna's. So now it's saying Bob is going along on his bicycle, and his velocity is measured by this equation. So they want to know, find Bob's acceleration at t equals 5. Well, if this is Bob's velocity, so this measures Bob's velocity, so his acceleration is going to be the derivative of that. So then I just plug in 5, because they want to know when t is 5. And I end up getting, now do not forget your units, and since it's acceleration, you should have meters per minute squared. Meters per minute squared. So that's kind of the gimme one. The parts A and C are the two that even if you don't get parts B and D, you should be able to get A and C pretty quickly. They're not trying to trick you or anything. And that's another thing about the test, is that a lot of the times they really are just asking you a really straightforward question, and the questions that are a little more complicated sound more complicated. So go with your gut and don't second guess yourself. Okay, on to part D. Part D probably requires it requires more work, definitely, than part C. So they want to know, based on the model from part C, find Bob's average velocity over the interval from 0 to 10. So average velocity, since they give you b of t, and this is the velocity, remember, think about this like a function. Whenever they ask for average value of a function or average velocity, they want this guy. So the formula from 0 to 10 of b of t dt over, now remember, this would be 10 minus 0, b minus a. So this would be from 0 to 10 of the function t cubed minus 6t squared plus 300 dt. And you can put a 1/10 out in the front if you want. So when I take the integral of that, I can just do it term by term. It's nothing fancy. Now again, you might say, oh, why do they have such annoying numbers? But they're really not that bad. And there's a lot of zeros, which is what they're hoping you will look at. Now, you don't have to remember, everything evaluated at 0 is going to be 0. So I don't even have to worry about, I could put it there minus 0 and then all times 1/10, but the AP test says you don't have to worry about doing that. So now I've got which ends up giving you 350. Now don't forget your units, meters per minute. So that is Bob's average velocity from 0 to 10. Now, again, you might say, why wasn't this a slope equation? Well, the average velocity, if they give you the velocity function, is that integral. If they ask for the average velocity and they're giving you the function, well, that might be different depending on how they're asking it. But if they're giving you the velocity function, then you can assume that you're supposed to do this, set up this integral. All right, that's question 3.